In this video, we'll examine how to integrate some powers of sine or cosine. For my two examples, I've chosen the integral of cosine squared of x and the integral of cosine cubed of x. Let's focus on the first one, cosine squared. The first thing I'd like you to notice is that the degree is even. It is cosine squared. When I have an even power, what I'm going to use are the so-called power reduction identities. The one for cosine says that cosine squared of x is equal to 1 plus cosine of twice x, the double angle is appearing here, over 2. A similar identity holds for sine squared of x. It's exactly the same, except notice that it has a minus sign in the middle of the expression. So 1 minus cosine still of 2x over 2. We're going to replace cosine squared with the right-hand side of the identity to get a new expression which will be easier to integrate. I have 1 plus cosine of 2x over 2 now. I'm going to rewrite this expression as two terms, so it's going to be 1 over 2, that will give me 1/2, and then 1/2 of the cosine of 2x appearing in the second term. I can now integrate both of these terms one term at a time, so the integral of 1/2 will be 1/2 x, and the integral of 1/2 cosine will give me some expression involving sine, but I'll have to account for the double angle, the fact that it's 2x here. I'll have to divide by 2 in my antiderivative. And there we have the antiderivatives of cosine squared of x. Simplifying, the 1/2 times 1/2 in the denominator here will give me 1/4 sine of 2x, and we're finished the problem. Let's now turn to this odd degree, cosine cubed of x. So this is an odd power. Using these identities won't help for an odd power, and in fact we can do something that's much nicer. What I'm going to do is split off one of those powers. It's going to be cosine squared of x times cosine of x, and my strategy will be to turn those even powers, the cosine squared, into sines. We're then going to leave this cosine of x and save it for a substitution in a moment. The identity that I need to convert the cosine squared of x to sine is just the familiar Pythagorean identity. It says sine squared plus cosine squared should be equal to 1. And I'm going to solve this for cosine squared of x. Cosine squared is 1 minus sine squared. So I'm going to replace the cosine squared, the even power, with 1 minus sine squared in my integral here. And we'll have the integral of 1 minus sine squared of x. And then remember, I'm saving this extra cosine for a substitution, because if I take u to be sine of x, its derivative is sitting right here that we've saved. So I'm going to let u be sine of x. The derivative of u is cosine of x, so du is cosine of x dx, which I've saved. And we can carry out the substitution now. It's the integral of 1 minus sine, so that's u squared. And then du is replaced with cosine of x dx. We can now integrate it term by term. The integral of 1 is u. The integral of u squared is u cubed over 3. And then finally we just back substitute and we replace u with sine of x. And there is our antiderivative. Let's just review what we did. In the odd degree case, what I did is I took all of the even powers and I converted them to sine squared. I saved one extra power for the substitution, so that was my derivative of u, the cosine of x. When I had an even power, what I did is I used the power reduction identities to expand out to terms that were easier for me to integrate.